Well, a warm welcome to everyone joining. Thank you for being here. Get yourself ready with a notebook. Grab a pencil or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have a problem in quadratics. We're going to be working with a parabola today. So a buddy of mine wanted to know the equation for a parabola. He drew a really nice parabola, but unfortunately he sent me a cutout picture which does not contain the entire parabola. Just, you know what a parabola is, it makes kind of like a U shape, so we know it's going to kind of do that, but we don't know the equation. And I asked him for the picture of the graph, but I only received this bottom portion. There was a piece that's missing, so that's going to cause a problem. I reached out to him and said, hey, I need the rest of the graph, otherwise I can't help you with the equation. But we'll just see what happens. For now, we have to work with what we've got, right? So the goal of this, the first goal, is we want to find out where is the axis of symmetry. Okay. The second goal for the problem is we want to find the vertex location, and we want to write the equation of the quadratic in vertex form. Remember that the parabola is the shape, the quadratic is the type of equation whose graph is the shape of a parabola. And then the third thing that we're going to do is we're actually going to write this out in a more full, complete form. We're also going to write the equation of the quadratic, but it's going to be in standard form. All right, and go ahead and give yourself some time to work this out. Now, you can't really find the second and third part of this until we receive the other information about the parabola. So for now, let's just work on part one, finding the axis of symmetry. Give yourself about 45 seconds or a minute to try to figure out how to figure the axis of symmetry. Remember that the axis of symmetry is basically just the x-coordinate of the vertex. It's the line of symmetry. Axis is just a fancy word that basically means a line. So the axis of symmetry is going to be the line where the symmetry occurs. Oops. And you should know that a parabola is symmetric, right? The graph of a quadratic is always symmetric. Well, we can use the fact that we have some nice intercepts to determine the axis of symmetry, because if this crosses through 0 here and this crosses through 0 here, then the vertex needs to be in the middle of these two. Sorry for the not so straight line. It needs to be in the middle of these 2 points. In fact, the vertex should be in the middle of any 2 points on the parabola. That's the beauty of symmetry. So we can very easily find the axis of symmetry by just determining what's in the middle of -2 and 6. And the way to find what's in the middle is very easy. All we have to do is add and divide by 2. It's kind of like taking the average. We're basically taking the average value, which is the value in between these 2 values, and that's going to be 2. And that sort of lines up correctly, right? You see that? I might use a different color than red since the graph itself is in a red. Let's look at x equals 2. It would make sense that that's the middle, but the question is, how high does it go? Actually, I just got some information. Oh my goodness. There's the missing piece that we're looking for. This is a piece that contains, it's still not the full graph, but this is a piece that contains the vertex, and it should belong quite a bit up here. See that that's lined up with the line? Yes. Now that we have the vertex location, you can kind of imagine what this graph truly looks like. Something like that, something like that, whoopsie, something like that. This is my OCD kicking in, I'm sorry. I don't have to put you guys through this. Yeah, here we are. Okay, here is the axis of symmetry going all the way up. It's going to hit the vertex at this location, 2, 16. So that tells us how high the parabola will go. How does this play into what we call vertex form? Yeah, vertex form is a very important format of a quadratic. If you have the vertex, you can very quickly put it into a vertex form. Remember that the vertex form of a quadratic looks like this. F of x equals some vertical stretch factor we call a. And then we have parentheses x minus h squared plus k, where the h and k just stand for the vertex coordinates. So the h we already found is actually the axis of symmetry, and the k, which is listed on the point, is the y value of the vertex. So in our case, we're going to be having f of x equals to, and if you'd like to give yourself, 3 or 4 minutes to try to work these out, I encourage you to do that. We have f of x equals a. We don't know what our a is because we're only looking at the vertex so far, but we know that the vertex is 2, 16. So here's our equation. It's not complete. We need to complete this. We can find the vertical stretch factor by using a point. In this case, we're going to use the intercepts. Those are the only points that we have. So any point on the parabola should agree with this equation if we plug in the x and y coordinate. We don't have any other specific values that we would want to use, although it does look like we have a nice little y-intercept of 0, 12. Let's pretend we didn't see that. Or you can use that if you'd like. I'm not gonna penalize you or limit you just because you were being observant. That's very observant. Or if you use this point 4, 12, that also works. But let's use these intercept points. These are pretty nice here. We have -2, 0, and 6, 0. Some people go with the positive one because it's positive. Some people go with the negative one because they think it's going to become positive. However you'd like to do it is fine. Let's use the point 6, 0. So remember that 6, 0 means the x value is 6, the y value or the f of x value is 0. So we have 0 equals a times 6 minus 2 squared plus 16. Well, that means that a times 4 squared plus 16 equals 0, which means that -16 equals 16a. And so we can pretty quickly determine that a equals -1. Okay, so the full vertex form equation for this is going to be f of x equals negative, parentheses, you don't have to write 1, of course, negative parentheses x minus 2 squared plus 16. That is the vertex form equation. Great. All right, so let's take a look at the standard form quadratic. What is the standard form quadratic? This is another important format for quadratic equations. It looks a little more like this, with everything expanded out, ax squared plus bx plus c. This is called a trinomial because it has 3 terms, 3 things being added. It's a quadratic trinomial because we have a highest exponent of 2. That makes it quadratic. Now this a is the same as this a, funny enough. So maybe I will write this with the same capitalization. Call this a. So we already have that in our back pocket. But if we didn't realize that, how would we get this equation? We don't need to use any of the points. That would be a more complicated way of getting it. In fact, let me write that as a note. Using points on the parabola would yield a system of linear equations. This system is solvable, but it is more time-consuming, and there are many more opportunities, that's how I'm going to write it, to make mistakes. So you don't want to create a system of equations that could be complicated to solve or just require a lot of calculations that you could make a mistake on. It would be better for us to just expand the vertex form, which does require a little bit of work, but it's definitely not as much work as solving a system of equations in 3 variables. We would be missing a, b, and c. Kind of tough to work with that. So let's expand the vertex form. We're going to start with this portion, which is squared. Let's open that up. So x minus 2 times x minus 2, that's going to give us x squared minus 4x plus 4, and then plus 16. So this is going to give us negative x squared plus 4x minus 4 plus 16 for a grand total. Pretty simple. Negative x squared plus 4x plus 12. That kind of cues us off to look at the standard form a little bit closely, because this value here, remember, this is literally the y-intercept. And we got a little sneak peek earlier at the top of the graph that the y-intercept is located at 0, 12. So if you were clever, you would have noticed that the c value is already revealed as 12. And then you might be able to use one of the points and find your a and b. I still think it's a great idea to expand the vertex form, especially if we already found it. Then we might as well just use that work that we did, and we can get a standard form equation. Now, let's connect this even further with the axis of symmetry. Let's double check the axis of symmetry and the vertex location. How do we do that? Well, this is a great opportunity to review how to find the axis of symmetry if we have an equation written out. Sometimes they give you the graph and you have to use symmetry to find the middle. Sometimes they give you an equation and you just have to use this nice trick. We say that the axis of symmetry is located at negative b over 2a, which in this case would be negative 4. See the plus 4? That's your b. Negative 4 over 2 times negative 1. See here that negative 1 is your a value. And that should give us negative 4 over negative 2, which is positive 2. That is indeed the axis of symmetry that we found. And then let's plug in that value and make sure we get 16, shall we? So f of 2 equals negative 2 squared plus 4 times 2 plus 12. This gives us negative 4 plus 8 plus 12. 8 plus 12 is 20. That's kind of nice. Negative 4 plus 20, of course, that's 16. So we're good to go. It checks out on the axis of symmetry. It checks out on the vertex location. We can be sure that this is indeed the equation of that mystery parabola that my friend didn't seem to be able to get the equation for. And of course, you might be saying, well, then how did they graph it on Desmos? Yeah, okay. You got me. Anyways, we've covered the quadratic form in vertex form, and we've covered the quadratic in standard form. I think that's enough blab out of me. I'll catch you guys next time.